Hello and welcome to today's class. For today, we're discussing on differentiation, right? As the question goes below, if y is equal to sin x, the y over the x is cos x. Proof. Why is it that if I differentiate sin x, I'll have cos x? Let's prove it here. If y is equal to sin x, if y is equal to sin x, the y over the x is cos x. Proof. First, I can actually prove this concept using what we call the first principle method of differentiation, right? If you don't know how to differentiate terms using first principle method, you can actually check our description of this video. I've brought a link on how to differentiate terms involving first principle method of differentiation, right? So our first task, first, I have that y is equal to sin x. We said for first principle method, what's the idea? The idea is that to y, I'll add change in y, then to x, I'll add change in x. Of course, for y, I'll add a change in y is not equal to, this is sine, then add what? X plus what then? Change in x. I have this, right? What's my next task? Obviously, I can take y here to the other side here. Hence, I'll have that change in y, per se, change in y is not equal to, if this one stays here, this one goes here, that becomes, I have sine x plus change in x, minusing what there? Minusing y. But from the question, but y was equal to, from the question, sine x, obviously, if I substitute sine x here, I'll have that change in y is equal to sine x plus change in x, minusing y is what? Sine x. I'll have sine x at this point, right? Sine x at this point. Of course, at this point, I will call a popular trigonometry function that says that if I have sine of a number multiplying sine of another number, what do? So recall from a popular trig function, recall that we said if you have sine a plus b, sine a minusing sine b, for instance, I have sine something minusing sine on another thing. I have sine a minus sine b. What will be the result? The result becomes 2 cos a plus b over 2, then what the sine a minus b all over 2. This is a popular trig function that says that sine a minus sine b is equal in value to 2 cos a plus b over 2, then sine a minus b over 2. When it comes to sine of a number, subtracting sine of another number, we assume that x plus 1 is x is a number and x is also a number. So when they are multiplying, the trig function says that sine a minus sine b is equal to 2 cos a plus b over 2 sine a minus b over 2. At this point, let's get a, let's get b. A obviously is equal to this man. This is sine a. Obviously, this is a. A becomes x plus change in x. Of course, get b. B is not equal to, what's b? B is x. So b is x. So putting this value here, I'll have that change in y per se, change in y is not equal to 2. I have 2 cos into, what is a? A is simply what? X plus change in x. I have x plus change in x. Then what? A positive b plus, what is b? B is x all over 2. I'm done with this. Next up, I have sine here. I have sine into a is obviously all this term here. That becomes x plus change in x minus, what is b? B is x. I have x all over what there? All over 2. Right? So at this point, what do? First, observe if you can see clearly. I can say that change in y is equal to 2 cos into x plus x becomes 2x then what? Plus change in x all over 2. I have this. Next up, I can also say that sine x minus x is off. I'm ready for change x. Change in x over 2. I have this. Right? I have this at this point. Alright. What will be our next task? Our next task is to divide through by what? The change in x. But before that, alright, divide by change in x means I can simplify as saying change in y is equal to, before dividing by change in x, observe something, this can be equal to 2 cos into 2x over 2, positive change in x over 2. I'm still correct. Right? From here, from the fraction law, if I add this together, I will have this back. Then what? Sine into change in x over 2. Of course, this one will cut out this. It's off. And remember, change in y is equal to 2 cos x, right, plus change in x over 2 in this manner. Then what? Sine change in x over 2. Right? So at this point, listen please. At this point, divide through by change in x. I'll have that change in y over change in x is now equal to 2 cos x, everything here, divided by change in x. So I have 2 cos x plus change in x over 2. Of course, sine change in x all over 2. I have this. Divided by what there? By change in x. Right? So for me to cancel out this man here, this 2 here, I don't need 2 here. So for me to take off 2, what do? I would divide numerator and denominator by 2. That's the concept. So making out numerator, I'll have that change in y over change in x is obviously, take that numerator. Numerator is obviously 2 cos x plus change in x over 2. Then what then? Sine change in x over 2. Then divided by 2 first. Next up, I'm having this over is here. Next up, change in x over 2. Obviously, this man, we cancel out this man. Left with what? I'm left with change in y over change in x to be equal to cos into x plus change in x over 2. Of course, sine change in x over 2. Right? All over change in x over 2. Right? So at this point, recall from trig function that says that if I have sine of a number divided by that same number, my answer there is what? 1. We go from this trig function that says that sine of a number divided by that same number is what? Is 1. I'll apply this concept here. In that case, I can have that change in y over change in x. So change in y over change in x is now obviously this man cos into x plus change in x, right, over 2. Then observe that this man and this will go together. So I'll be having multiplied by sine change in x over 2 divided by change in x over 2. So divided by change in x over 2. We just said that if I have sine of a number, remember that same number, I have 1. Of course, sine of this, remember this same this is what? 1. So here is 1. Alright, we just said sine change in x over 2, remember change in x over 2 will be 1. Why? Because we just said sine of a number divided by that same number is 1. Of course, in that case, I'll have that change in y over change in x, change in y over change in x is now equal to cos, I have cos x plus change in x over 2, Abi. Next up, times this becomes 1, right? Becomes 1. I can multiply by 1. Of course, this times this is what is here. All over this man here. Over 1 will be here. So we see the same thing with this, please. See the same thing. It's just different in expression, right? So I have this. Alright, at this point, I said that for limit, when you divide through by changing x, and you're still left changing x, what do you do? You take limit of in x to be what? 0. So limit of changing x to be 0, I'll have that anywhere changing x, I'll put 0. Of course, I'll have that change in y over change in x is obviously cos into x plus change in x is what then? 0 over 2 times 1. Times 1 is of course 1. I have this off. Right? Hence, at this point, change in y, change in x is equal to, this is cos x. Then 0 by 2 is what? Of course, 0. 0 plus a is what? Still x. Change in y over change in x is only cos x. So this is a proof to whenever you differentiate sin x, I'll have what the cos x.